I'm Gabor. I'm looking at things from the other side of things. An AI engineer here at Resolve, hoping to give you guys a perspective, maybe more from the trenches of what it looks like to actually be building these experiences, or what it at least feels like to build these sorts of experiences. Uh, so the main lesson that I think I want to convey is a bit of a contradiction. AI is both magical, but in kind of an ordinary way. So what do I mean by that? I mean, like when I think of magic, I think, Gandalf in the Mines of Moria, you shall not pass. And then off screen, something happens. Magic happens and the Balrog disappears. I've been fortunate in my career, both at Resolve and previously at Google DeepMind, to get to witness that fight, so to speak, to see what that magic looks like. And it's not that it isn't magical. It's very clear that AI can do things that I would never imagine, even as an AI researcher, AI engineer, would have been possible. Uh, but uh, it's doing it in a very ordinary way. Uh, and what do I mean by that? Uh, I mean that it looks a lot like how the rest of work, the rest of software looks. The fundamental reason for this, I think, is that the capabilities of LLMs are still uh, very much in line with the capabilities of how other AI systems over the past couple of decades have worked. There are things that the engineers and researchers at Google and OpenAI and Anthropic care about and put into their data sets, and there are things that they don't. And so these AIs work better at the things that these companies care about. You can test this yourself. Ask an LLM to write a very complex JavaScript web app, and it'll do a fantastic job. Ask it to go to Java, and it'll do an okay job. Ask it to go write, Fortran, and I mean, it'll do something because they are generalizable, but it's not like no one at OpenAI cares about how good Fortran coding capabilities are for these models. And what that means in practice is that as an AI engineer, I spend most of my time projecting the capabilities of the model onto the task that we're actually doing. And this is a very ordinary sort of thing that we do all the time in software, where we have, the capabilities of a programming language that we project onto the task that we're trying to solve. And it has the same sorts of complexities to actually launching and rolling out in production. You have to build the code. And in the same way, you have to build the data set or build the prompt for the AI system. And much like code, what do? You write something, you run it a few times, you see if it works. Invariably, when you show it to other people, they use it in some new way. They ask new things, they send different data through it. And you have to play this game of whack-a-mole of fixing the code to make sure it works for all of the inputs. Similarly, even prompt engineering and certainly data set collection, you have to you roll it out or show it to some people, they ask all sorts of stuff you don't expect, and you have to adapt the system. You have to build out this system to handle that range of outputs, which leads naturally to, how do we do this in code? We write unit tests. The equivalent of unit tests in AI systems is evals. Helps the whack-a-mole somewhat in the same way that unit tests help you have certainty that when you make a change in code, you didn't break everything that came before. But even there, like unit tests, when you run the code, it does the same thing every time. LLMs, not so much the case. So you get a number, but it's not necessarily telling you, hey, here's precisely what went wrong and how you're likely to fix it. And then the last thing that, of course, we know from software engineering is actually maintaining things that are out in the wild has a maintenance burden. LLMs, this actually kind of surprised me when I started properly rolling out LLM applications. But even for prompted applications, this is true. And like one side of this is more clear. Bug reports come in that want new capabilities. You have to adapt the system and continue to improve. But even if it's just in pure maintenance mode, eventually the models deprecate. Eventually, you have to move from one model to a new model. And it turns out that prompts certainly, translate to some degree, but not perfectly. And data sets similarly, depending on what model you start from, you'll have oftentimes substantially different characteristics when you retrain it on a new base. So what am I trying to get at here? I think oftentimes we view LLMs as like a way to magically get around the difficulty of building a complex piece of software. or we only look at the complexity from LLMs from the perspective like how do we actually tie together all these APIs and build the system. And I think this is a fallacy. It turns out that there are a bunch of things that make the building and maintenance of AI systems, and especially as you compose them into these sort of larger and larger agentic AI systems, that require a substantial amount of burden, not to prototype, but to like actually roll out into production. All right, so the other side of this is it's been a very negative talk so far of like, hey, AI is very hard, which is true in some ways, but like so is software. Uh, Clearly, the answer is not to never build software. We're all software engineers here, or at least in the software industry. And in the same way, clearly, it's not the case that you should never build your own AI system. You should never build your own agentic system. The big question is, where is it going to provide the most value? Where should you actually be building it? And for this part, I'm actually going to take off my AI engineer hat and put on just like my regular software engineering manager hat. Uh, the way I think about this is I treat AI very similar to how I treat regular software engineering. When do I build versus buy something in some product that I'm building? Uh, well, a good litmus test in my mind is to think about whether I'm describing this thing that I'm building as a component of the system or as an obstacle that I have to overcome to launch it. So components are things that my team is good at, or I'm good at if I'm building it. Components are things that bring differentiated value to the product. Components are things that that our engineers want to build. This is a thing that they'd be happy to build and maintain. Obstacles are everything else, and there's a bunch of obstacles, a bunch of things that are not core, but maybe either flourishes or more commonly just a thing that has to be there for the product to work, but can be more commodity. And just to make things concrete, I'm actually going to go back one step further in my career to Square, where I led an AI team and actually the infra team that was building Square Messages, a two-way communication platform between buyers and sellers within the Square ecosystem. And the AI side of the team around 2020, 2021 or so started looking seriously into LLMs and how we can bring AI and these suggested replies to this messaging system. And so this is a bit of a contrast of things that I think we should have bought and things that I think we were right to have built. This is a case where actually I think we were right to have built the AI. Like at the time, GPT-3 was the best system that was available, openly, and we made the decision deliberately to make our own, to fine-tune our own at the time GPT-2 model. So it's even a smaller model that we could build internally. The reasoning here, A, we had a dedicated AI team that could do it. B, we had a whole bunch of data that gave us a competitive edge in building it ourselves versus just prompting a system. And C, it was a thing that was important for the product. Like regularly, we heard the feedback that sellers wanted to sound more professional. They wanted to sound like it came in their tone, or at least a tone that was customer support ease, so to speak. And this is something that we can get much more reliably if we, throw a whole bunch of data at it and train a custom model, as opposed to trying to finagle a public system to do the same. And it was an important feature of the product. This was one of the main selling points and main driving points of why people would come to Square and Square Messages to get. By contrast, and this is a classic mistake, I can, I can say I was younger and more naive. But at the time, we also hosted our own models. We had GPU nodes on Kubernetes, and we had a service that we booted up. And the assumption was like, oh, it's not hard. Like Kubernetes is there. How hard is it to just like run a main method in some PyTorch code? And like that was almost certainly a mistake. We spent a whole bunch of AI engineering time on maintaining the system that just didn't need to be maintained for the product to work. It was very commodity to have somewhere that serves a PyTorch model. And then we could have put the logic into our main service rather than say AI service that was backed by a backend team that had all of its infrastructure already around it. And so, there's an example of this contrast between components the actual main model that was that formed the backbone of Square's AI or Square Messages' AI product versus an obstacle. We have to host the model somewhere. That probably we should have just used something commodity. And so for final thoughts, maybe I'll try to put myself in the shoes of somebody building these systems, which I guess I am at Resolve, and advice to leadership. So maybe I'm indirectly talking to my uncle or something here. But a couple of points that I think are important takeaways. I mean, one which we've touched on a couple of times here is to put engineers on mission critical stuff, not on things that, even if they're exciting, are fundamentally, just obstacles that are relatively commodity. Similar to that, keeping in mind that AI systems have a testing and maintenance cost. The building cost is also there, but I think that one's better understood. Testing, that is making evals for these systems, and maintenance, that is keeping the prompts and the data sets fresh over time, I think are much less understood in the zeitgeist of agentic development. A natural conclusion of this, putting more energy into fewer AI applications. This is a big theme at Google, that everyone was complaining that like AI is being spread everywhere. And I think it's kind of right that it would have, it's a better idea to pick a few places where it makes a big impact, where it's a differentiator to the product. And where as an engineer, I can put the effort that I want to put into to make it great, rather than trying to rely on this generalizable purported magic of AI to work for everything everywhere all at once. And almost in contradiction to that, also letting us hack. I think from like putting on my eng manager hat, the reasoning here is it gives you a good sense of what is feasible and what is not, and what are the places that you should be putting energy into, rather than like fully staffing all these projects. First, go let people do it in 20% time, or AI hack days or whatever, and then pick the few. And the other, just greedily, they're fun to build. The anecdotes I'll give, both from Google. One of my friends there was the tech lead for Gemini Canvas, and he just has a blast, vibe coding AI applications on Canvas that call the Gemini API, and complains regularly when a new model comes out and he has to update the prompts and the systems for Canvas to adapt to this new model, in the next week when the old one will get deprecated. Similarly, I worked on a project at a hack day at Google that was a blast to work on. Spent a week hacking it out, and then it took months thereafter to get it to a state where it's actually ready for launch. And so I think the separation is both fun and healthy for at least me as an engineer, and I don't think I'm alone here. And with that, I'm going to finish up my take.